All right, so what I'm going to do is I'm going to start with matrix addition and matrix subtraction. So let me go back to lecture 4 when we have that. Okay, from here for example 2, starting with example 2. All right, so in order to have matrix addition and matrix subtraction, of course, you need to input some numerical calculations. So you start with import numpy as np, right? For easy setup. Now you need to enter the matrix in, right? So matrix A is np dot array, right? Open parenthesis, bracket. Then you input what you have for the matrix. So the first row is 1, 2, and the second row is 2, 3. So that is for matrix A. Okay, so this is the matrix A right here that I'm using, that I'm taking from example 2. B, we cannot do anything with B. We cannot combine A with B because they are different sides. So the only matrices that we can perform the calculations on are matrix A and matrix C. So matrix C is equal to np array. The first row is -7, 4, and the second row is 1, 5. Okay. So you have matrix A, you have matrix B. So let's print out the matrix just to see what they are. Right. So matrix A, matrix C. Now to calculate matrix multiplication is very simple, right? So let's say you have the results is equal to A plus C, and then we're going to print out the results and see what happens. Right. So quickly you get the matrix from the additions, right? A plus C give you -6, +6, 3, and 8. So this is the same with the result that we got in the notes. So let's do matrix subtraction. So the same setup, right? Same A, same C. The result now, instead of an additions, let's do subtractions. And you got the matrix of A, -2, 1, -2, again, which is similar to, or exactly the same with what we have in the notes. You can do the same for the case of C minus A. Right. You have a different answer, right? So this calculation A minus C and C minus A, I try to illustrate the fact that there's no commutative property for matrix subtractions. So A minus C is different from C minus A. In fact, C minus A is equal to negative of A minus C. So A minus C different from C minus A. Then you get the scalar multiplication. If you have a number, you multiply that number with the matrix and see what you got. All right, so now I'm going to move on to example 3. Do you have any questions you follow in with the code that we have now? All right, let me move on to another cell. So import, I still want to import numpy as np. And for example 3, this is a 3 by 3 matrix. So let me set up the matrix. So matrix A is np.array. Open parenthesis, open bracket. So the first row should be 3, 1, -1. The second row is -2, 8, 5. The third row is 6, -4, -3. Right. So again, let's print out matrix A and see what happens. So that's a 3 by 3 matrix that you got there. Okay. So in example 3, you want to find 3 times A. So the result we're looking for is 3 times the matrix A. Okay, and then let's print out the matrix A results. So that is the result that you got when you multiply a scalar with a matrix. Right? So you distribute 3 into every single element or every single entry of the matrix. So 3 times 3, you get 9. 3 times 1, you get 3. 3 times -1, you get -3, so on and so forth. Okay, so that is the scalar multiplications of a matrix. Now we're going to move on to matrix multiplications. And this is where we go to example 4. All right. So remember, I asked you, the questions in the homework is that I asked you to perform the calculations by hand, but later on we also have some problem related to using Python to solve the solutions. Okay, so example 4, you have 2 matrices A and B, right? And you need to calculate A times B. So let me start with again numpy as n. Sorry, import numpy as np, and you set up matrix A and matrix B. So matrix A. The first row is 2, -1, -1. The second row is -2, 1, 2. Now for matrix B, and p dot array, the first row is 1, 3. The second row is 2, 0. The third row is -1, 2. All right, so you have A and B. Now you perform a matrix multiplication. So how would you do that in Python? So in Python, there's a syntax, just one line of code that allow you to do matrix multiplications. That is, so let me do results is equal to np dot, another dot, the word dot, so dot, and then matrix A and B. So this indicate that this line of code tell you that can you perform a matrix calculation, matrix multiplications where A is on the left of the matrix multiplication and B is on the right of the matrix multiplications. Okay, so in matrix multiplications, the order on which you have the matrix matters, right? Run the code. Of course, you want to print out the results. All right. So when you run the result, print out the result, and you get the matrix of 1, 4, -2, -2, right, which is exactly the same with what we have in example 4. All right, so let's move on to example 5, when you have a 2 by 3 matrix and a 3 by 4 matrix. Now I'm going to start everything over again just so that you have multiple line of codes in your notes. Right, so again, import in numpy as np, set up matrix A, set up matrix B. So A is equal to np dot array. The first row is 1, 3, -1. The second row is -2, -1, 1. And matrix B is np dot array. First row is -4, 0, 3, -1. Then second row is 5, -2, -1, 1. The last row is -1, 2, 0, 6. So perform A times B. You do results equal to np dot A comma B, and you print out the results. And you get that 2 by 4 matrix. So the entries are 12, -8, 0, -4, 2, 4, -5, 7. So which is exactly what we have before here. You can do the same thing for other calculations at this point. Hopefully you get it, you see how it's done, and you can perform the calculation using Python by yourself. Now let me move on to lecture 6, when we have the inverse of matrix. Okay, so there's two calculations. So in example 1, you have two 2 by 2 matrices. Right? We need to perform A times B and B times A so that we can have the resultant matrix to be identity matrices. Right? And to show that A and B are inverses of one another. So let me do that. So again, you import numpy as np. You set up matrix A. The first row is 2, 5. The second row is 1, 3. And matrix B is np array. First entry is 3, -5, and -1, 2. So you're going to have two different results here. Result 1 is equal to np dot AB, right? So the first result tell you that can tell machine that can you perform a matrix multiplication of B first and then of A first and then B. Okay, so let's print out result 1, and then you're going to have the second result where you have np equal to dot of B comma A. Let's print out the second result. You run the code, They both give you identity matrices, and therefore you can conclude that okay, A and B are inverses of one another. So to find the inverse is not too difficult either. It's just one line of code. You have a 2x2 matrix. You have a formula that you can perform, right? To get the inverse of the matrix. So let's do that. So you do import numpy as np. So you set up the matrix A just like we did before. So array. The first entry, the first row is 1, 2. The second row is 3, 4. And to find the inverse, right, so let's say inverse, what you do is that you do np dot len alg to indicate linear algebra dot inv to calculate the inverse, right? So inv is the short form of inverse of matrix A, right? And you print out the result of inverse. So, and you get the result to be -2, 1, 1.5, -0.5, which is exactly what we have in the notes, right? So instead of using fraction, they use decimal points. So -2, 1, 1/2, and -0.5. Now let's say in the case that you have a non-invertible matrix, what's going to happen? What kind of message you're going to see? So in this case, let's set up matrix B, do the same calculations to find inverse and see what kind of error you're going to have. Okay, so I still, as a practice, do this. Import numpy as np, set up matrix B as np array. The first row is 12, -15. The second row is 4, -5. And then let's say you want to find inverse of a matrix, right? So here you do np dot len alg to indicate linear algebra package that we're going to use, and the calculation is to find the inverse of the matrix B. And let's say you want to print out inverse, and you see that you get some error here, and here for the error you have singular matrix. That is, you cannot find the inverse of the matrix B, or B is not invertible in this case.